So in problem 12, we're told that we have an 8 milligram injection of dye. So that's what's going up here for my A. That's our 8 milligrams injection of dye. And a 2-second interval readings are shown in this table. And we're asked to use the midpoint rule to estimate the cardiac output. Right away, if I know we're talking about the midpoint rule, that's how we're going to be estimating something around an integral. So we're going to be replacing this integral on the bottom with an estimate using the midpoint rule. The table, and I'm not going to rate the entire table out, but the times on the table span from 0 all the way to 20. There's kind of a trick in here in that because it's asked us to use the midpoint rule, I just got a warning, I just got a warning that my video is lagging. So I'm going to switch over to a different Wi-Fi network really quick. Okay. So I will need you to let me know if I'm still lagging really badly right now. I'm going to keep going, but I'll watch the chat. And if you all tell me I'm lagging really badly, then I might end up just recording this and posting it later. Okay, back to the problem. So the t values in the table in the problem span from 0 to 20. Because we've been asked to use the midpoint rule, the increments that the data points are at are in 2-second intervals. There's a trick there that if I'm going to use the midpoint rule, that means that I have to split this into sections that are twice the width of the intervals given. So I actually need to split this to go 4, 8, 12, and 16 so that I have midpoints to be able to estimate the values at. Now, that C of t, we're going to estimate this using the chart, and that dt will be our delta t, which is going to be that 4 seconds. So our numerator is 8, and in our denominator, that delta t of 4, I would take the value of c from the midpoint of that region. And based on the data, c of 2 is 2.4. So my first piece down here would be 2.4 times my delta t. And then I'd move to our next midpoint, c of 6. And c of 6 is 7.8. So I'd have 7.8 again times our delta t. And I'd keep going until I got all the way to c of 18. There isn't really a whole lot conceptual going on in this problem. I think the biggest jump was recognizing that in order to use the midpoint rule, we weren't given an n and we weren't given a delta